Hello my dear students, how are you all? Welcome to Diksha Karnataka YouTube channel. Today bacha, I'm back with a very important session of Decode NCERT. The chapter is integration, right? One of the highest weighted chapter in your syllabus for your PU2 boards, right? So as you know, we are decoding our NCERT, what question to solve, what concept to revise, everything has to be done, okay? So whatever it is, we'll see that. I'll give you question list, I'll tell you how to approach particular questions, how can you make this easy, everything will be discussed bacha in detail for this analysis of this chapter, integration, right, from the NCERT. So I hope you're ready for that. Let's have a look, sir. Coming up first is going to be bacha, of course, the formula defining the integration. What is that, sir? Antiderivative of the function. Antiderivative of the function, that's how we define bacha integration. Please have a look. So we have written over here the problem of finding a function wherever its derivative is given. What you used to do, function was given, finding derivative, right? Differentiation we used to do. Now ulta, differentiation is given, find the function from there. Now there we use bacha antiderivative of the function, okay? Now that part is used in, again, two approach we have. One is for, we have with indefinite integral, right, where we have a constant of integration, and bacha we will also have definite integral, right, where we don't have a constant, simple value will be there with the help of both upper and lower limit. I hope this is clear. Chaliye. So we have, again, you can see here indefinite and definite parts. Now we'll quickly go on to look at the formulas that we have to do, okay? So this is differentiation, we can just reverse it to get the result for integration as well. So we will show you the formulas, just give me 1 second, okay? Very big chapter bacha, so you'll have to spend some time over here. We have here thus important definitions regarding the integration as well. Think about it. If you integrate fx dx, how we read this as integration of f with respect to x. The reading of this function is this way bacha. So this table is very important, okay? Simple, very simple, you already know it, just have a look anyway, okay? Just have a look anyway, okay? What is fx means? Integrand over here, x is the variable of the integration, integrate means basically finding the integral, okay? Integration means the whole process is integration, okay? And constant of integration, that comes in case of indefinite integral, right? I'm not teaching anything, just letting you know, you have to study this part bacha, okay? Now please have a look. So if you are continuing from here, next important part will be the formulas. This side we have derivative, this side we have integral. So please remember all these formulas, okay? Don't worry, I have highlighted over here. You have your NCERT book, okay? It's available for free on the NCERT official website. Go ahead, take from there. If you don't have the access to the latest version, if you have, very good, okay? Otherwise you can get a soft copy available for free. Otherwise, what you can do is, you've already joined the WhatsApp channel, right? You'll get this sessions PDF given to you with all the highlights in that WhatsApp channel only. So don't worry about any of the things, okay? So have a focus over here. So we have bacha for polynomial function x power n plus 1, differentiation and integration. Again, you have, sir, differentiation of a function just given as x, okay? Or integration of a constant function 1 is simply x plus c. For trigonometric functions, sir, sine, cos, like that, we have all of these formulas that you have to remember bacha, okay? You have to remember. This is the most basic. This is like, if you don't know this, then I don't know what to say to you. You have to know these formulas, okay? For inverse trigonometric function, for logarithmic functions, for trigonometric functions, for polynomials, for constant, all of this has to be bacha learned, okay? So I hope this is clear. This is very, very important. Now moving on. Total of 13 formulas are here, so know all these formulas, okay? Not if and buts, not sir, okay, I might forget some, not like that. By heart means by heart. One way to do is like practicing so many questions on it, it will become automatically in your head. Otherwise, right now if you don't have time to solve all those questions, what you can do is just remember these formulas, couple of times go through it, you'll have it in your mind, okay? Now bacha, we'll move on to some properties of indefinite integral. Let's have a look. Very important, this one. If you integrate, if in the question they have simply given differentiation of some function, if you integrate bacha, you'll get the function directly, okay? Chaliye, derivative of f is given, if you integrate, you'll get the function directly, and the constant of course will come because of the indefinite integral, sir. So one property is that, okay? Next bacha, let's have a look. This, if you have to integrate, let's say two function, okay, you can do them individually also. See, integration of fx plus gx can become integration of fx plus integration of gx. Simple. Again, the property of indefinite integral. You actually use it without knowing it. Same this, right? Whenever you have a constant multiplier to the function, you can take constant outside. Remember 1 by 2 is taking outside, something like that is there. A constant e is given, we take that outside as well. So whatever is the constant, you can take it outside the integration and then integrate the function whichever is given there, okay? With respect to the variable of the integration x, X is what, sir? Variable of integrals, bacha. Yes. So these are the properties for the indefinite integral. Okay, now again, if you have series of integration like this, k f1x, k2 f2x, like these functions are there, you can integrate them individually also, taking k outside and f1x integration first, f2x integration second, and like that. Very simple properties of indefinite integral. Yes, when it comes to the properties of definite integral, that might be a little challenging, but don't worry, we'll deal with that over here only. Okay, so we'll get to that later. Right now, let's go ahead and do the questions in, or understand the questions which you have to do in indefinite integral. So, okay, now please have a look. But example number 2 I have highlighted over here. Please solve these questions. So I have given more emphasis on the example side, so you do not miss out on any questions in example side. That's a must do. Okay, if you can solve, Ashad, whatever questions I'm giving you, those are minimum number of questions from this chapter. You can solve more than this, but not less than this. I hope you get it. Okay, minimum of this has to be solved because of the time at hand. If you can solve more, if you can solve faster, if you can solve questions in your mind, better, very good. Okay, but minimum this must has to be solved, bacha, for this chapter to be, you can say that, okay, I am done with this chapter, moving on, I can solve any p by q. What's the step? All these questions, if you're done with it, very good. If you can solve all the p by q's also comfortably, then you are done with the chapter. Make a tick. Integration is over. Okay, example 2, sub question 3, bacha, simple question. Check this out. You have over here polynomial function, over here exponential function, over here logarithmic function. I'll show you the answer also. Part 3, please solve it. Please solve it. I'll show you. Yeah, so see, exponential form, sorry, polynomial form, exponential form and logarithmic form in the same question. That's why I have marked that particular question. So whatever questions I've marked, no, they're good questions, so please don't ignore them. Example number 3, bacha, part 2 and part 3, solve these 2 questions as well. Solve these questions. Okay, example 3 and example 2, don't worry about the question, don't list it out, don't write it down right now. You can just get the sessions PDF and take it from there. Okay, don't have to write anything, just listen to me, a quick video will discuss everything in the chapter quickly. Okay, so don't write anything right now, just have this look on the video. So question number 2, question number 3 from this example number 3, bacha. Next, moving on, we have, let's see, exercise. I have marked here question number 12, question number 13. Okay, next, bacha, we have marked here 16, 19, and one more thing, I am asking you, making a request, please solve all the MCQs from NCERT. They are very less anyway, but please solve all the questions of the MCQ side. They are marked over here in every exercise. Question number 21 and question number 22, bacha. So both these questions you have to solve, and we have already given here 16 and 19. So less questions over here, simple only. That's why not spend that much of time in the first exercise and examples. Some questions I've given, that much you can solve. Now MOI, method of integrals. You have couple of methods, 3 actually. You have, sir, by substitution becomes the most important method, sir. Why? Because a similar approach will be used in differentiation and other questions as well. Okay, so that's why basically in AOD or AOI you will have this, approach utilized a lot of times. Okay, that's why it becomes very vital to you to know integration by substitution by heart. Okay, means it should be like a feeling. You look at a question, you should be getting the substitution. How can you do that? By solving numerous questions on this particular topic in MOI, method of integration. The first method is very important. Second, again, it's important, sir, because question comes on this, but this has application everywhere, bacha. Even in this, no, you might use the application of substitution. Okay, substitution is like fundamental, that has to be done, and that has to be you have to be very good at the method of substitution. Okay, now next, bacha, by partial fractions, and last is by parts. Both of these questions are coming actually straight forward. They give you one question on partial fraction and they will give you one question in by parts in the exam. If you've seen the trend, if you go and check out the blueprint out, you'll find the questions available on this. Okay, and whatever question paper I've solved for all of you, you might have seen there. Okay, chaliye. Now let's move on. Integration by substitution. In that, bacha, what do you do over here? When you use this, whenever you find some way to identify the derivative of the function available in the question itself, means whatever they're asking the integration for, derivative is also present there. Okay, whatever derivative is present there, that derivatives, whichever the function derivative is, that you take that function as substitution. Right, I'll show you in the questions, don't worry. Check this out. So in this particular question, bacha, I already have GT derivative over here. GT function is in the question, okay, and derivative is here. So I'll take what? I'll take this GT as some other substitution. Okay, chaliye, I'll show you over here. Check this out. I have 2x. I have 2x over here present. Okay, over here I have, bacha, 1 plus x square, the derivative of tan inverse of x. Okay, over here sir, I have sec square root x and by root x present here. It will become the derivative bacha. So please check this out. I can take tan root x as the substitution. I'll show you. Check this out. Tan root x the substitution. Question number 3. Or they have taken only root x. Okay, substitution is where? Here. So root x as t they have taken, but you can take tan root x also. Yes. Okay. It will become sec square, no? Tan will become sec square, that's what I'm saying. You can take root x also, not a problem, but you can take tan root x as the t. It will become bacha t power 4. This will be 1 by 2 will be present over here, of course. You'll again be part of the dt only. 1 by 2 t power 4 dt should come. Can you get that? Try it that way as well. So they have given an answer for this with the approach of root x taking as t, but you can try this tan root x as t and let me know whether it is correct or not. Do one thing, try this way and let me know in the comment section. If you want to do it right now, pause the video, do it right now, let me know in the comment section. I'll get back to your comments and let's see. We'll have the discussion. Okay, just try this tan root x as t. Okay, chaliye. Again, I have marked this question, bacha. Please solve this. So 2, 3 and 4. Okay, example 5, 2, 3 and 4. Let's move on now. Let's move on to some important integrals, bacha, for trigonometric function. Root of tan. Usually what we remember, na, derivative of tan is what, sir? Sec square, not a problem. But integral of tan, sir, log of sec x. How, bacha? Differentiate this part. Log of sec, bacha, what will happen? Sec will come down. Okay, log sec will come down. And differentiate sec, bacha, it will become what, sir? It will become what? Okay, sec tan x. Okay, so what you can do here over here is have they taken, yeah, they've taken the derivation over here. 1 by t log t becomes log cos x. There's a minus sign, it becomes sec. How come, sir? If you take minus sign over here, it will become what, bacha? It will simply become, sir, 1 by cos. How much is that? Sec. Correct, na? So you can write this or this, both is correct. Okay, so this formula is very important, not the derivation, the formula is very important. Cot x integral is also there, bacha. Log sin x we have for sec x, log of sec x plus tan x. For cosec x, log of cosec x minus cot x. Okay, these formulas should be with you all the time. All the formulas in this integration has to be with you. Questions have been asked even in the differential equation. I have solved a question for you where we had to find the integrating factor and that was given as sec x. So what was the answer? Log sec x plus tan x. If you remember, then good. If not, then please check the sessions. Okay, I have done a question, I think in Brahma series, or I think that was in the regular KCET series also. But I think I've done a question like that where we had to find the linear differential equation with the help of integral of log sec x. Okay, sorry, yeah, sec x becomes log sec x plus tan x. Okay, this formula I'm talking about. This formula, sir. Okay, so you have to remember all these formulas. So only 4 are there. I think you can do it on this particular kind. Now example 6, bacha, I marked here 2 and 3. Please solve these questions. Please solve these questions. Have a look. I'll show you again over here. Okay, x plus a as t over here in this part. So this becomes x equals to t minus a, and then you have to write the formula of sine of t minus a, sine t cos a minus cos t and sine a. Okay, divided by sine t, differentiate this, you're gonna get this as cos a constant is like this, and over here you'll have bacha cot t, sine a is a constant, integrate this, simple answer. Okay, so simple questions are there. Even the third one, please solve this. Okay, tan as cos, and then you have to make this. Check this out, cos plus sine, cos minus sine. This becomes what? Cos of x minus cos x minus sin x. You have this again, integration this, we can take this as cos plus sin x becomes t. This part becomes t, it will become log of cos x plus sin x. I'll show you. Log of cos x plus sin x, somewhere here. Log of cos x plus sin x. Check this out. Don't worry, I'm not rushing through this thing. I'm not teaching you to solve the question over here. You can solve it from your side as well. I'm just letting you, these are good questions, please solve them. Okay. So I can show you again part 2 and part 3 of bacha. Example number was, have a look, 6. Example number 6, part 2 and part 3. Let's move on to next section. Exercise now. Okay. Exercise. Chaliye, same thing was that. Exercise 7.2 bacha, question number 14 we have, question number 20 we have, and then we have to solve 24, 30, 35, 36, 37, 38 and 39. MCQs I've mentioned over here. So all these questions have to be solved. Don't worry about the numbers. Get the session PDF and you can refer from there. Okay. Chaliye, moving on to, sir, integration using trigonometric identities. Okay, where we have to use the sine 2x, cos 2x, sine 3x. Okay, we have to use other formulas. Cos 2x has 2 formulas, 3 formulas. Tan 2x is also there. So we have to use all these formulas. Okay. So yes, you have learned this already in grade 11, basic PU 1 for you. What you have to do is remember all the formulas from there. You just make a list of it, and then you'll be, I'm telling you what, sin 2x, cos 2x, tan 2x, sin 3x, cos 3x. These are the most useful ones. So write all these different forms of these formulas. Okay. Check this out. Cos 2x is used over here, bacha. 2 cos square x minus 1 the formula is. Okay. So all of this has to be done. Know all the formulas. Exercise 7.3, check this out. I've mentioned here some questions. 12, 15. So 12, 15, 17, 18, 20, 22, and 23 and 24. All these questions has to be done in trigonometric identities integration. Okay, clear? Let's move on now. In particular functions, we have some particular functions, bacha. 1 upon x square minus a square integration is there. Okay, 1 by 2a log x minus a upon x plus a, and we also have a square minus x square, where we get a plus x a minus x upon a plus x upon a minus x. Okay, this one. Okay, so there are 6 I think, yeah. So all the 6 has to be memorized, bacha. I know it's tricky, but I have taught you how to memorize that. There's a link between it. Okay, so I have taught you in that session. So you have to remember all these formulas. Questions comes on this. Questions comes on this. You have seen this in the PYQs also. Okay, in the Brahma series as well. Okay, and I've solved all these questions. I've done Brahma series in detail, bacha, for all these questions. So especially for continuity and differentiability, and for this chapter, I've done 2 sessions in Brahma series. So go ahead, check that out. I've done a lot of questions of different variety. Okay, both from NCERT and PYQs. Okay, chali. So remember all these 6 formulas from particular function. Okay, derivation you don't have to. Actually, you can. Very important, because what happens now, particular functions, they ask the derivation and then a question based upon that. So do one thing. I know it's a little harsh to ask, but yes, please do the derivations of all these particular functions. They're not difficult, right? Just you have to use the right substitution, bacha. So please go ahead and do that. Once you do that, what will happen? You will be able to score marks. That comes, bacha, in your examination. 5 mark question is there. That comes, okay, or 3 marker, 5 marker, they are asking this question, they'll give you a derivation, and based upon the derivation, they'll ask you a question on it. So you'll have 2 parts in it. So please solve this question, okay? Basically, please solve this derivation, okay? For particular functions, it becomes very important. Only for particular functions, okay? Only for particular functions, not others I'm asking, okay? Chaliye. Next, sir, we have to find the integral of this form. We have some separate form, bacha. So not these forms, they don't ask that generally. They ask those only, a square minus x square minus a square with the root, without the root. Okay, so not those only are usually asked, but over here we don't have derivation as such. We have the form, how to use it, how to solve questions on it. I have marked enough questions, don't worry. If you solve all these, you'll be very clear with it. Okay, this part is very simple. You have to make this the denominator in that one of the form of particular function, right? Check this out. Using this plus minus k square, and then you have to use, bacha, what? Using what, bacha? You have to make this condition, okay, and use one of the formulas that you have, one of the 6 formulas, whichever suits, to get your desired integration result. Okay, now second, 8th condition, bacha. Again, you have a root over here. The formula will be of that kind, root of a square minus x square, or x square minus a square, or plus a square, whatever it is, you have to use that formula if you have a root present over here. So basically, in the condition 7 and 8, you have to use the formula from 1 to 6 only. Just you have to make some transformation of, by using what? Making a perfect square in the denominator by the formula a plus b the whole square, or a minus b the whole square. I know you can do it, right? I've done questions on this. Okay, chaliye. So 9th, bacha, this is very important. What you have to do is differentiate this part, okay, to get the value of a and b. Compare this. Whatever you have in numerator, right? Compare that with the differentiation of a multiplied differentiation of the denominator, and compare the this end and this end to get the value of a and b. Capital A, capital B, because this, bacha, 2ax and all will be known, right? It will be known to you. I have taken here ax square plus bx plus c, right? Actually, a and b, c will be known, bacha. Variables are only, the variables over here are only a and b, capital A and capital B. P is known, Q is known, A, B, C is all known. Only capital A and capital B is unknown values, okay, which you have taken the constants. Differentiate this, get the coefficient of A as 2x plus B, and then compare this px plus q and this to get the result for A and B. What you can do is substitute x as something and get the value of A and B. Once you do that, then this, you can replace this, bacha, px plus q. You can replace this px plus q by this term. Once you have the value of a and b known, then there are no variables involved over here. Replace this px plus q by this form, then you will be able to solve this question. Don't worry, I'm gonna explain you this. Again, same format is there for this if you have root in the denominator. I've taken questions like this, so I'll show you. Example number 9, bacha, part 2 and part 3. You have to make perfect square. I'll show you that part again. Part 2, have a look. Perfect square in part 2. Yes, please check. X plus 13 by 6 the whole square. X plus 13 by 6 the whole square. It becomes the formula of x square minus a square. Becomes the formula of x square minus a square. So see, t square minus that value. So log of t minus this value by t plus this value. Then switch back that value of t to the in terms of x. Right now, t is a substitution, right? You have to substitute back the original variable. Okay, so that's why t is switched back in terms of x and then simplified to get this answer. Okay, got it? So the question was given like this. Okay, you made this into a perfect square format, x square minus a square. Why that's a? Because the formula is given that like that, you know. Whatever the formula suits out of the first six particular functions, you have to remember that. Okay, and then suitable formula you have to pick, use that integration and then substitute back the original variable. Okay, I know it's complicated, kind of challenging, but with practice it will become easier, bacha. You can solve these questions. Okay, 3 also you can solve. This also, bacha. Check this out. Making a perfect square over here, again same approach. X square minus a square, right? Log of t plus root of t square minus 1 square, sorry, a square, same root, and you can substitute back this t value as in terms of x. Okay, solve it. It's not that difficult. Okay, find the following integrals. Again, this condition, bacha, we have to equate x plus 2 to differentiation of this with a plus b. Check this out. X plus 2 to differentiation of this with a plus b. So you get a times of 4x plus 6 by b, and which will give you, if you solve here, bacha, coefficient if you equate for x, you're going to get a as 1 by 4, b as 1 by 2. Now just simply remove this x plus 2 as this, bacha. This whole thing, where was it? This part. A 4x plus c, 4x plus 6 times of a plus b. Check this out. What is a value? 1 by 4. 1 by 4 is coming here. This part as it is, denominator as it is, and then bacha comes what? Plus b is 1 by 2. The same thing repeats. Okay. Why it repeats, sir? Because we are putting this numerator, no? Why denominator is there? Because we are putting this x plus 2 in terms of this. X plus 2 in terms of this. So put it here. Then separate with the help of the plus sign. Correct, na? Remove x plus 2 and put it this in place of that and separate this two fractions with the help of plus sign, and then rest is integration. Okay, please solve this question. Good question. Okay, so they have done it separately. You can do it in one way as well. Good question, bacha. Third also you solve. Okay, second also you solve, I mean. So now let's see what else. Exercise now. I have marked so many questions over here. Please solve these questions. Question number 12, question number 13. This is about exercise 7.4. So question number 12, question number 13, question number 20, question number 23. Okay, see, this is the same category. We have px plus q here, px plus q here, and this is in the form of root to solve this question. 23. Next, bacha, MCQs. So 24, 25. Please solve these questions. Okay, simple enough only. Just apply the same concept that I've explained to you right now. I've taught you that as well. Okay, now moving on to bacha, integration by partial fractions. Okay, this is important. One of the question is coming, either this or a particular function will be given. Okay, usually they give both also. The high weightage chapter is there, no? So usually they give both also. This can give, they give in 3 marker also. They can give you this question in 3 marker, and then particular function they can give you in 5 marker. Okay, chaliye. So let's have a look. What do you do in partial fractions, sir? We separate with the help of this table, sir. We have this forms given, okay, for rational functions, and this is the partial fraction that we have. When we have 2 factors, simply write it as a by x minus a and b by x minus b. When we have whole square, write like this: a by x minus a, b by x minus a the whole square. When we have 3 factors, comes the 3 different variables a, b, c. Okay, and then you compare the numerator to find the values of a, b, c. I can substitute back bacha x as something, b 3 times, and get the values of a, b, c. I have taught you the methods to find a, b, c as well. Please go ahead, check my sessions on Brahmas series, okay, or in integration in KCET series. Okay, chaliye. So all different subtypes of rational functions are given here, and their partial fractions also given here, partial fractions. So make use of this table. This has to be in your mind all the time going in the examination. This is very, very important, okay, for partial fractions. Chaliye. Now let's look at the questions. I think you've seen this question. I think this was also a PYQ similar to this. There was a question like this in PYQ as well. Okay, so I hope you have solved that. Now what's example 12? This is you have to solve. Very simple. Solve this question number 12. Example 13, sir. simple enough. Okay, example 14, sir. Yes, example 15, sir. As I said, I've given preference to the examples. Less questions in the exercise, but more questions in the example category. That has to be done, non-negotiable. Okay, example 15, bacha. All right, it'll require substitution. You can take it like that. Example 16, bacha. Okay, so different types of partial fractions are there. We have made use of all of them. Exercise 7.5, we have taken question 14, 15, 16, 17, 18, 19, 20, 21, 22, 23. Okay, these are MCQs. Okay, and the other questions you can see once again, 18, 19, 20, 21. So basically from 18 to 23, all the questions you have to solve. Don't worry about the list of the questions. You can get the list of the questions with the PDF in the WhatsApp channel. I'm repeating it again and again. If you have watched it over here only, very important to know where to get the PDF. WhatsApp channel, if you're not joined yet, join right now. The link will be given in the description of this video. So please go ahead, join and get the sessions PDF. Any update will be also given there. If you're not able to join, let me know in the comment section. We'll again get back to you. Okay. Integration by parts, bacha. Over here what we use, the ILATE rule, the preference order we know, ILATE. Inverse trigonometric function comes first. Okay, then comes your logarithmic function. So IL, inverse trigonometric function, logarithmic function, A, algebraic function, T, trigonometric function, and E, exponential function. ILATE, correct? Inverse, logarithm, algebraic, trigonometric, and last is exponential function. This is the preference order to name the function, function 1 and function 2. Very important, because you're going to integrate with the help of this only, no? This, whatever is function number 1, excuse me, keep that as it is. Integrate the second function. Integrate the second function. Now minus sign will come. There will be an integral. Differentiate the first function. Differentiate the first function that you have. How to choose first function, bacha? Based upon the preference order that you have. ILATE. I hope this is clear. First function differentiation. Now multiply that with second function integration. And then again the product what you are getting, integrate that again. Okay, so integration of the product of differentiation of the first with integration of the second. I'll repeat, integrate the product of differentiation of the first and integration of the second. So there is a two integration over here. First comes here, same thing repeats over here, product now integrating again. That's your by parts rule. Doesn't look, it looks complicated over here, but in questions it actually is very simple. All of you agree? Okay, chaliye. So same thing is written over here in the language. So check this out. We have x cos x, so preference order, sir. Algebra comes first, then comes the trigonometry, A, T, E, no? So A comes first, so first function, cos is second function, okay? That's why x is first and cos is second function. So apply the formula, x as it is, cos integration, x differentiation is 1, cos integration, product is going to be, bacha, what? Sine only, no? Check this out, sine only. Alright, sir. X is going to be x square by 2. Again, bacha, we can integrate this. Alright. Let's move on to next, sir. Question number 18, sir. You have to solve this. Well, nothing is there means you take 1, bacha, second function. Nothing is there means take 1 as the second function. Check here, nothing is there, no? Take into 1. I can multiply 1 to log. Nothing is there, just log is there. Means multiply 1 to the log. And what will happen? It will become a second function. Then use the by parts. Use the by parts. Yes, chaliye. Example number 19, bacha, example number 18, example number 20. Okay, we have to solve all these, and then bacha, we have integral of some types also are there. What is this? What is this? Very important. I've seen this question in your PYQs and multiple occasions we have solved these questions. Okay, wherever you have e bar x integral with the presence of fx plus f dash of x, means the function and the derivative is both given in the summation form. Function and the derivative is given in the summation form with multiplication with e power x. What is the answer, sir? Simply e power x fx plus c. Simply e power x fx. Where is it? Simply e power x fx plus c. That's your answer. Okay, for this integration. Question is coming on this. Okay, just you have to verify the function fx and f dash of x. Okay, chaliye. This is the formula over here. Solve this question. Example 22, part 2. Okay, I have highlighted it over here. 7.6, bacha, I have given you a lot of questions on this side. 10, 11, 12, 15. 7.6 comes next is 19, 20, 21, 22, and then bacha last 2 as the MCQ. So all MCQs has to be solved. You have to solve this, must. There are only 2 MCQs, right? So please solve these questions anyway. Do not miss out on this. Okay, so 23 and 24. Now 7.6.2, integral of some more types. This bachcha again, x square minus a square, x square plus a square, integral of root of a square minus x square, and x square minus a square. All of this is very, very important. Okay, the same thing, right? Same thing. Questions are coming on this as well. Questions are coming in on this as well in your boards and in your KCET as well. So in the KCET also they have asked this kind of question. I've done that in PYQ as well. So I hope you have checked that out. Over here, derivations, you can do it, not a big deal. Okay, so give preference to the derivation of your particular functions first, then you can, if you have time, do this as well. Question can be asked, bacha. They'll give you this integration as a derivation, then ask a question based upon this 5 marker. Very important. Okay, now with the formulas are listed over here, second and third, have a look. 1 by 2x, even this question was asked in, and I have taught you this in KCET as well. Okay, questions I've taught you on both these formulas. Okay, so remember this, example number 23, bacha. This is given like this, you have to make the perfect square. So there is it, x plus 1 the whole square plus 4 means it becomes x plus 1 the whole square plus 2 square. Take this out. The formula is used like that. Very simple. Just only the making the perfect square part is going to be challenging. Once you do that, formula, if you remember, very simple. 1 by 2 y, the same root repeats, plus 4 by 2. So basically it is a square by 2 log of y plus same root repeat. Okay, plus c. Now put back the value of y in terms of x because we have the variable given as x for the integration. Okay. Example 24 now, same approach, bacha. Example number 24, exercise 7.7. Let's have a look at question list. 3, 9, and bacha, we have 10 and 11. MCQs. Simple questions. I have given less over here, so please solve these questions. 3, 9, and 10 and 11. Now moving on to definite integrals. So first category is done. Moving on to definite integral. Okay, fundamental theorem of calculus. Area function. Please have a look. Go through it. Okay. That's how you find this area. A to x fx dx. Okay, for this function particularly a to x fx dx. Chaliye. Next bacha, first fundamental theorem of integral calculus. This substituting the limit f of b minus f of a. That's how you use, bacha. Okay, to find this definite integral when the limits are given, upper and lower limits. Okay, let's have a look at the questions now. Acha, before that we'll move on to the properties, right? Okay, some questions are given here. So example 25, 3 and 4 I've highlighted over here. Please solve these questions. Okay, next bacha will be having 3 and 4 is there. Okay, next sir, what 7.8 bacha. Example number, so question number 7, question number 11, question number 13, 17, 20, and the MCQs. Please solve these questions. Very simple they are actually. Just on the properties. Okay, like basically you have done this kind of question in the indefinite integral just using the limits form. Very simple I've given, and we've given less questions also. How many questions I've given here? So 1, 2, 3 and any more? 1, 2, 3 and okay, 2 more, there is 5. Okay, 5 questions in the and 2 MCQs, only 7 questions are there. Please solve this quickly. Okay, you can solve this in your mind also. Just use the substitution part. Okay, clearly fb minus fa. For substitute upper limit, take care of minus signs here. You make mistake in minus sign in the substitution of limits. I know that because even when I was a student I used to make that kind of mistake. Avoid that. Okay, please avoid that. Now some properties. Okay, with the help of substitution over here, this is very important, sir. Whenever you have substitution involved in definite integral, it's very important to change the limits as well. What you do is you take the right substitution, you solve the question, but you do not change the limit. Then it becomes difficult, bacha. Your answer will be completely incorrect. So what you do is, there are 2 ways to do it actually. One thing is solve the entire question by the substitution, and at the end switch back to the same variable, original variable, and then use the limit. Otherwise, if you're writing the limits every time, then you have to write the change in limits also. Let's say the function is changed from x to t. Okay, the function of integration, sorry, the variable of integration is changed from x to t. The limit has to be also changed from for x to for t. Means for x, the limit is 0 to 2. Okay, for x the limit is 0 to 2. Then what is the limit for t? Is it 1 to 2 or 1 to 5, whatever it is? Okay, change limits as well. Don't forget that. Okay, I know all of you will relate to this. You have somewhere in your practice you have forgotten to switch back the limits and got the answer wrong. Don't do that in the examination. Please start from here only to write the change in limits in the beginning itself when you're solving the question. How you solve the substitution question? You take a substitution, you find the derivative to change the dx part, and you have to make the third step in this category. What is it? Change of the limits. Substitution, taking the substitution, differentiation, and change of limits should be coming all together. Then you go to the question. Agreed? Okay, sir. And now have a look at the questions. Example 26. Okay, example number 27 also bacha, solve this as well. Simple na, tan inverse of x is there, you will take this as t, it will become 1 plus x square will become dt, right? This will become dt, dx by 1 plus x square, dt bacha. Change limit also, 0 to 1 will become, check this out, 0 to 1 will become 0 to pi by 4, 0 to 1 will become 0 to pi by 4, check this, change in limits, very important. Okay, exercise now, question number 5, question number 8, question number 6 and the 2 MCQs. Again only 5 questions I've given over here, please solve it. Now properties, this is very important. All the properties of different integral are very important bacha, because questions will be asked on this and you should be able to recall all these to be solved the question. Okay, so first property is from a to b, you can change the variable. If you have function in terms of x to dx, okay, make it ft dt, no change in the limits. Means x can be changed to t, but everywhere, not only in the t and dx. Let's say you write this as ft and keep this as dx. Incorrect. Change everything. X dx you can change everywhere to x to t. All the variables x to t. Okay. Same bacha, you can interchange the limits by using a negative sign. If you have a to b, you can write this b to a with a negative sign. Okay. Again, a to a will be bacha always 0. How come so? Integration of a to a always 0. Why bacha? fa minus fa na. F of a, let's say the function fx comes as gx, okay? After integration fx becomes gx. What is the answer for the upper limit? G of a, lower limit sir, g of a. Subtract them, 0. So from a to a, if you are integrating, it will become what? It will become 0 sir. It will become 0 sir. Now a to b can be divided in between with another constant number c, a to c and c to b. You can do more than once also. A to c, c to d, d to b. A to c, c to d and then d to b. You can divide it multiple occasions. Okay, you actually do that whenever you have done with questions on modulus, right? I think you have remembered this from the previous sessions that I have conducted, right? In the modulus question we break this function, right, to make it positive or negative, right? So we have to take a to c, c to b, and if you want you take more, c to d and d to b. Okay, so property number 2, we have over here writing this. What you do is whatever the limit is given, you can just add them and just subtract x from there. If you do that, so replace this x by a plus b minus x. What is a and b? A and b are the limits. So add the limits and then subtract the x from there. If you put it in place of x, the integral will remain same under the same limits. Then integral will remain same under the same limit. Okay. P4 sir, 0 to a. Same thing, but same property actually. This P4 is based upon P3 only. 0 plus a minus x. So a minus x. Okay. Chaliye. So P4 is a particular case of P3. Same thing I said. You can divide bacha 0 to 2a, 0 to a and 0 to a. Correct na? 0 to a and 0 to a. Chaliye. Okay. P6 sir. 0 to 2a can be written as 2 times of 0 to a. If it is coming as 2a minus x as fx. Okay. And if it is 0, then 2a minus x as f minus of x. How sir? Even an odd case. Even an odd case. From here sir. P7. Check this out. Minus a to a integration. Okay. 2 times of 0 to a you can write in the case of even function. I have done this derivation at multiple occasions. It is a part of PYQ also. Please cross check the question in your Brahma series. I have done this there. Okay. In NCERT I have done. Please go ahead and check it. Okay. Part 2, and you can take it in PYQ also. I think it will be there in PYQs. Okay. Please cross check. When it is bacha odd function will become 0. I have done the derivation in detail. Please go ahead and check. Odd function will become a 0. How it becomes a 0? I have done the derivation. Okay. Chaliye. Let's move on to the questions now in the properties section of different integral. What we have, sir, example number 28, please solve this. I told you, modulus function whenever we have, we look for critical points, okay, and then you differentiate this minus 1 to 2 between multiple limits. Have a look. Minus 1 to 0, 0 to 1 and 1 to 2. Minus 1 to 0, 0 to 1 and 1 to 2. We can break bacha, properties of definite integral, okay. Example number 29, please solve this. Example number 30, example number 31, okay. Example number 32. So many examples. Yes, but you have to solve all the solved examples. Okay, over here. 33 also we have, and 34 also we have to solve. All these questions are very important. 34, and now moving to exercise 7.2, 7.10 I think. Yeah, 7.10 bacha. Question number 2, question number 9, question number 11, question number 12, 13, 15, 17, 18, 19, and the MCQs. Yes sir, so many questions. High weighted chapter bacha. These things has to be done. I can't help it. Now the last section, what is it sir? The miscellaneous examples. Miscellaneous has to be done also as well bacha. Example 35, okay. I have mentioned all the examples over here. Miscellaneous category, everything is important. okay, because these questions can come in even in KCET also, they might come, okay. You might have seen the PYQs, some questions can be repeated there as well, okay, and in the boards also they keep asking these kind of questions. That's why very important to learn this, okay. So all the examples are here, 36, 37, we have bacha 38, yes, all the examples as I said, 39 also, integral of cot x plus tan x, okay, root tan x is taken. I think I've solved this question, I have solved this kind of question, okay, I think in Brahma series, please check. 39 I have done, 40, okay bacha, 41, 42, yes, 43 I think, is there a 43? No, there's not 43. So solving all the solved examples of miscellaneous, all of them, please solve it, all of them. Do not, do not do anything else. Follow my words, solve all the questions, bacha. Very, very, very important. You can see I have not given so many questions. I have not asked you to solve all the questions. I have picked questions for you. Okay, I have given you the question list. How can you get the question list? WhatsApp channel. You have joined, very good. If not, join it right now. Get the session PDF. Okay, very important. Your Decode NCERT is going on right now. Exercise on chapter 7. Okay, miscellaneous exercise, bacha. Please check. Question number 2, question number 5, question number 8, question number 10. 13, 15, 16, 17, solve these questions, sir. They're all different questions, so please solve all of them. They're all different questions, bacha. Don't write one and skip the second one. Because I have already skipped the questions, right? So you have to just solve whatever I've given to you. 17, okay. Then, bacha, we have 20, 22, 23. Then, sir, 28, 29, okay. 31, 34, 37. And then, bacha, MCQs 38, 39, okay. 38, 39, and of course, sir, 40 as well. 40 as well. So I've already given you minimum possible questions from this chapter. I know it's a lot, but chapter weightage is also higher, bacha. So this has to be done. One more thing, solve more than this question, not less than this. That has to be a must. Like whatever I'm saying, this has to be done completely in that way. You have to solve minimum of this question. Please do that. You will actually feel confident in the chapter, and you can solve any PYQs if you are able to solve all these questions. I'm telling you, and then you are prepared for this particular chapter. So I hope this session was helpful. If you want, you can revise from the summary also given. Everything is given at one place. You can revise from here as well. Okay. So, bacha, this completes the session over here for integration Decode NCERT. Okay. I'll see you in the next session of the Decode NCERT. Till then, you have to take care of yourself and solve. This is actually like a homework. Okay. Decode NCERT is about a homework session, bacha. I'm coming here to give you some task. You have to do it from your side. Of course, you will do, and let me know in the comment section that you have completed it. Okay. I'll see you in the next session. Till then, you have to take care of yourself. Keep working hard. See you. Bye bye.